We're going to talk about quadratics and the idea of stretching today. I want to start with a table. If we have a function in table form, and this is a table of the function f of x equals x squared, but we don't have to know that. We can see the x value that was plugged in and the resulting f of x value. So what if I asked you to make a table of 2 f of x? Hopefully you'd understand here, even if you haven't seen it before, that our x values that we put in, 0, 1, 2, 3, 4, 5, wouldn't necessarily change, but the resulting y value would be multiplied times 2 or doubled. So the 0 value here would get doubled, resulting in still a 0. The 1 value here would get 2 times that f of x value. The 4 would get doubled, the 9, etc. On a table, it's pretty easy to understand that this 2 multiplying times the f of x only affects the f of x. When we look at a graph of x squared, and this is our standard parabola, and then look at a graph of 2 times x squared, what we see is our y increases much faster. And that corresponds with what we saw in our table. As the x marches along, the y increases much faster when we multiply by 2, which would make sense because we're doubling it. So what if I were to put a 5x squared? What would we expect that to look like? Hopefully you were correct in guessing that that y increases 5 times faster than the original. I'm going to zoom in down here. Instead of being through that 1, 1 dot, notice our 2x squared and our 5x squared increase much faster. In fact, our 2x squared goes up to 2 at the x value 1. And as you can probably guess, the 5x squared crosses the x value 1 right here at 1, 5. So we've seen how doubling x squared makes it go up twice as fast. Multiplying by 5 makes it go up 5 times as fast. So what do you guess that multiplying by 1/2 does? As we can see here from my new dark purple parabola, it goes up half as fast. Instead of going up to that 1, 1 dot, the y value is affected and only goes up half as far here. Instead of 2, 4, it only goes up half as far to 2, 2. Notice that I'm not looking at any effects on my x value. I'm looking at how this affects the y value and changing the y's dot by dot. So let's look at a graph that has some vertical, horizontal shifting, some reflection, and then let's add some stretch to it. So hopefully we start with the x. We see that's an x squared, and we know that that's a parabola. If I were drawing this by hand, that's where I'd start then, is by drawing my basic parabola centered at 0, 0 with a dot through 1, 1, negative 1, 1. Draw that U shape. From there, I'd notice I'm being shifted. Even though this says negative, I know that's being shifted to the right 2 units. I can imagine my vertex moving 1, 2 units to the right. And here I've done that, shifted my parabola 2 units to the right. What I see next is this negative attached, which takes my parabola and flips it from a smiley face into a sad face. And here you can see I've performed that flip and I have that frowny face umbrella opening downward. Finally, I have a shift at the end of +1, taking my vertex, which is centered at 2, 0 and shifting it up 1 unit. So you should be able to go step by step through each of these transformations, starting with our basic parabola. What I want to add to this today is the idea that we put a 3 or some other multiplier in front of that x squared term. Well, based on our basic parabola, which has been shifted, it has been reflected, it has been vertically shifted, what we now have is this stretch occurring. That means in case of this parabola, from the vertex, as we go over 1 unit, instead of going down 1 unit, our new parabola will go down 3 units. Starting from the vertex the other direction, as we go over 1 unit, we will no longer go down 1 unit. We will triple that and go down 3 units. Please remember our vertex has been affected by the shifting here, but no other part affects the vertex. As soon as we know what kind of shift occurred here and what kind of shift occurred here, our vertex is defined. This 3 is only affecting our y's, how fast or slowly it increases or decreases. So let's draw on that graph now. And we see it does in fact have the same vertex. It just goes down faster and a factor of 3 times faster. Thanks for watching. Hope this helps.